Multiple types of interference exist on a network, one of which is PIM interference. So, what is PIM interference? In a linear system, there will be two output frequency signals in the case of two input frequency signals, and no new frequency signal will be generated. However, in a nonlinear system, new frequency signals are generated in the case of two input frequency signals. The new frequency signals are known as intermodulation products, and this phenomenon is called intermodulation. Intermodulation interference, also known as PIM interference, occurs when intermodulation products fall within the receive band and uplink interference increases. PIM interference is generated when passive components such as connectors, feeders, antennas, and filters work at multiple frequencies. Now, let's take a look at how PIM interference affects network performance. Assume that PIM interference signals generated during downlink scheduling fall within the uplink frequency domain range of a cell. For example, in a two-carrier scenario, if downlink center frequencies of the two carriers are separately F1 and F2, then a PIM signal with a center frequency of twice F1 minus F2 is generated. In this case, PIM interference is imposed on the whole uplink frequency band of carrier 2. Therefore, PIM interference affects the uplink network performance of the cell served by carrier 2. To mitigate the impact of PIM interference on the network, Huawei provides the intelligent PIM interference avoidance solution. This solution involves two phases: intelligent PIM interference detection and intelligent PIM interference avoidance. Now, let's take a look at how intelligent PIM interference detection works. First of all intra-base station cells that share the same RRU and channel in a base station are grouped into an intermodulation cell set. For example, cell 1 and cell 2 are in an intermodulation cell set. Secondly, the base station obtains information about the uplink and downlink frequencies and bandwidths of all cells in the intermodulation cell set, calculates the center frequency and bandwidth of PIM interference, and determines whether a cell suffers PIM interference based on the relationship between the center frequency and bandwidth of PIM interference and the uplink center frequency and bandwidth of each cell. If a cell suffers PIM interference, an intermodulation pairing group is generated. For example, in this intermodulation pairing group, cell 1 is the victim cell, and cell 1 and cell 2 are interfering cells. Finally, during off-peak hours, for example, in the early morning, the PIM interference strength of each intermodulation pairing group is detected. Specifically, full load simulation is performed in all interfering cells in the intermodulation pairing group to stimulate the strongest PIM interference, and uplink interference detection is performed in the victim cell. Then, uplink interference detection is performed in the victim cell without load simulation in interfering cells. The difference between PIM interference detected in the preceding two cases is the uplink PIM interference strength. The PIM interference detection result is used for intelligent PIM interference avoidance. Now, let's move on to techniques related to intelligent PIM interference avoidance. When the uplink PIM interference strength is greater than the threshold, intelligent PIM interference avoidance is performed in the victim and interfering cells separately. As for the intelligent PIM interference avoidance in victim cells, RB-based avoidance in uplink scheduling can be used to reduce the interference frequency domain range of victim cells. As for intelligent PIM interference avoidance in interfering cells, RB-based avoidance in downlink scheduling, downlink power reduction, and channel isolation for PIM interference avoidance can be used to reduce the interference frequency domain range and interference strength of victim cells. Here, let's see how RB-based avoidance in uplink scheduling works. During uplink scheduling in a victim cell, the non-interfered RBs are preferentially selected for scheduling based on detected frequency domain positions of interfered RBs. This reduces the frequency domain range of PIM interference. So, how about the function of RB-based avoidance in downlink scheduling? Based on the frequency domain positions of interfered RBs obtained through intelligent PIM interference detection, this function calculates the frequency domain positions of RBs that cannot be used for downlink scheduling of interfering cells, and avoids these RBs as much as possible during downlink scheduling to reduce the frequency domain range where PIM interference occurs. Well, let's move on to downlink power reduction. When PIM interference occurs in a majority of the uplink scheduling frequency band of a victim cell, and the RBs that need to be avoided in downlink scheduling of interfering cells account for a large proportion, the downlink power reduction function takes effect in the interfering cells to reduce the strength of PIM interference. This function directly reduces the downlink transmit power of interfering cells. For the NR system, channel power reduction for PIM interference avoidance is supported. Based on the PIM interference detection result on each channel, this function reduces the power of only the channel that suffers strong PIM interference. Here, let's see how the channel isolation for PIM interference avoidance works. It is recommended that channel isolation for PIM interference avoidance be enabled when uplink KPIs significantly deteriorate and the uplink becomes basically unavailable due to strong uplink PIM interference. In this case, the transmit channels specific to different carriers can be isolated to mitigate PIM interference. For 424R cells, the number of downlink channels of the two carriers sharing the same channels is reduced from 4 to 2. For 8T8R cells, the number of downlink channels of the two carriers sharing the same channels is reduced from 8 to 4. That's all about intelligent PIM interference avoidance. For more details on this solution, scan the QR code on the screen.